Engineer Contreras, and our topic for today is counting techniques. So here we will be talking about permutations and combinations. First is permutation. It is a mathematical technique that determines the number of possible arrangements in a set when order of the arrangement matters. Under permutation, we have linear permutation. It is a permutation in a straight line. First case under linear permutation is taken all at a time. That is taken n all at a time. This is the formula that we'll be using. Npn is equal to n factorial. For our example, how many permutations can be made from three distinct objects all are taken at a time? Okay, so we have here Npn is equal to, we have three distinct objects, all are taken at a time. So that is 3 factorial, which is equal to 6. Next is taken r at a time. So we have here r at a time. Taken all things distinct or different. Please take note of this. Okay, so this is the formula that we will be using. NPR is equal to n factorial over n minus r factorial. Or you can make use of your permutation function in your calculator. That is at shift multiplication function. Okay, so for our example, we have here, in a game of high ally, players are numbered from 1 to 10. The first player to score 9 points will be the first placer, and the next two highest scorers will be declared second and third placers. Each bet must consist therefore of 3 numbers corresponding to the player number of the first placer, second placer, and third placer respectively. Neglecting the possibility of not having second and third placer, how many bets are possible? Okay, so here the problem suggests that there is an arrangement. Okay, so our n is 10. Okay, so 10, then of course this is permutation, and our r is 3. That is for the first, second, and third. So we have there 10 p3, that is equal to 10 factorial over 10 minus 3 factorial. Okay, this is equal to 720. Okay, so or you can use your permutation function in your calculator. That would be 10, then shift, then the multiplication function, then 3, then equal. Okay, that will give you 720. Next case, taken all at a time, some things are identical. Okay, this is the formula that we'll be using. We have NPNI is equal to n factorial over I 1 factorial, or that is also the first identical factorial times the second identical factorial, and so on. For our example, how many permutations can you make out of the letters of the word Padilla if all letters are taken at a time? Okay, so as you can see here, we have identical letters. So this is NPNI, that is equal to, how many letters do we have? We have 1, 2, 3, 4, 5, 6, 7. So that would be 7 factorial divided by, what is the first identical letter? We have A. So that is 2 factorial times, we have L. We also have 2 L. So that is, again, 2 factorial. So this is equal to, we have 1260. Next is for the circular permutation. So it deals with a number of ways of arranging things around a circle. The first case is taken all at a time, all things distinct or different. So this is the formula that we'll be using. NPCN is equal to n minus 1 factorial. So for our example, In how many ways can you sit in a three-couple circular table of 6 seats if one occupies a particular position? So this will be NPCN is equal to, we have 6 minus 1 factorial, and that is equal to 120. Another case, taken all at a time, some things are identical. Okay, so please take note that the above formula may only be applied provided that at least one thing is distinct. So this is the formula that we will be using. We have there NPCN is equal to n minus 1 factorial over the first identical factorial times the second identical factorial, and so on. For our example problem, in how many ways can you arrange 6 chairs in a circular position if 2 of which are identical? So we have there NPCNI is equal to, we have 6 minus 1 factorial over 2 factorial, and that is equal to 60. Next case, not all things are taken at a time. All things distinct or different. Okay, please take note of this. All things distinct or different, and not all things are taken at a time. So we have here NPCR is equal to NCR times R minus 1 factorial. This one is for the combination. Okay, so you can use the combination function in your calculator. That is at shift divide, okay, or the division function. Okay, so for our example, how many circular permutations of 4 objects can you make out of 6 objects? Okay, different objects. So we have here our n is 6, okay, times, okay, we have C4, okay, 6C4 times, we have R is 4 minus 1 factorial, and that is equal to 90. Okay. Next is permutation by group. Group here is defined as the collection of things arranged in peculiar ways. So we have here PG is equal to G factorial times N1 factorial times N2 factorial. G is the number of groups, N is the number of things in the group, and N2 is the number of things in group 2. For our example, in how many ways can you line up 4 Marines and 6 Army soldiers if all the Marines must be side by side with each other and the Army soldiers are likewise? So we have here 4 Marines and 6 Army soldiers. Okay, so we have here PG is equal to, how many groups do we have? We have 2. So that would be 2 factorial. And then the Marines should be side by side with each other. So this is considered as one group. So we have here 4 factorial. Okay, and another one is the Army soldiers. They have their own arrangement in their group, just like the Marines. So we have here 6 factorial. Okay, so that is equal to, we have 34,560. Okay. Okay, so in the last problem, what if all the Marines must be together while the Army soldiers need not be necessarily together? So how many ways are possible? So the Marines should be together. Again, how many Marines do we have? 4 Marines and 6 Army soldiers. So the Marines must be together while the Army soldiers need not. Okay, so we have here 1 group and the 6 Army soldiers. So that is 6. We have 7. So we have here PG is equal to 7 factorial times the arrangement of the Marines in their group, that is 4 factorial. Of course, for the armies, we have 1 factorial times 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 1 factorial. Okay, so we have here, this is already 1. Okay, so that would be 7 factorial times 4 factorial. That is equal to, we have 120,960. So, for the combination or selection, if in permutation, arrangement or order is very important, in combination, it is the grouping of things whose arrangement is not important. So, first case under combination, we have there all things distinct or different. So, this is the formula that we'll be using. NCR is equal to NPR over R factorial or N factorial over N minus R factorial times R factorial. Or again, as I have mentioned earlier, we can use the combination function in our calcu, that is at shift divide. Okay? So, for our example, how many number combinations are there in Lotto 649? So we have there, note that each combination consists of 6 different numbers selected from 1 to 49, wherein the arrangement is not important. So we have here 49, C, 6. Okay? So we have there 49, C, 6. That is 13,983,816 number combinations. Okay? So, next, a semiconductor company will hire 7 men and 4 women. So we need 7 men and, please take note of this, and 4 women. Okay. So, in how many ways can the company choose from 9 men and 6 women who qualified for the position? Okay. So we have here 7 men and 4 women. That is 9 available men, and then we need only 7 men. So 9 C7 times, since this is and, so we need to multiply, or we can use the multiplication rule of counting here. So for the and combination, we have there times, how many women do we have? 6, and we need only 4. So we have there 9C7 times 6C4, that is equal to, we have 540. Okay, please take note of this. If it's and, we multiply. If it's or, then we add. Okay? Next is a combination of things taken 1, 2, 3, 4, or n at a time. So we use this formula, C is equal to 2 raised to n minus 1. So, example, in how many ways can you fill a box with books if you can choose from 6 different books? So that would be, we have 2 raised to 6 minus 1, that is equal to 63. Okay? For our additional examples, so in a city, the bus route numbers consist of a natural number less than 100, followed by one of the letters A, B, C, D, and E, and F. How many different bus routes are possible? Okay, so what is the number less than 100? The natural number less than 100 is 99. Okay, times, okay, 1, 2, 3, 4, 5, 6 letters. So that is 99 times 6. We have 594. Next, there are 3 questions in a question paper. If the questions have 4, 3, and 2 solutions respectively, find the total number of solutions. Okay, so we have there 4, 3, and 2. So it's simply 4 times 3 times 2. So this is equal to how many? We have there 24. Okay, so in how many ways can an animal trainer arrange 5 lions and 4 tigers in a row so that no 2 lions are together? Okay, so here we have the arrangement of the lions and the arrangement of the tigers. We have there 5 factorial times 4 factorial, that is equal to 2,880. Next, in how many ways can the letters of the word leading be arranged in such a way that the vowels always come together? Okay, so what are the vowels in the word leading? We have E, A, and I. And of course, the consonants are L, D, N, G. Okay, so the vowels should be together. So this will be considered as one group. Okay, and of course, these are 4. Okay, so we need to add, we have there 5. So that's 5 factorial times the arrangement of the vowels. That is 3 factorial times, of course, 1 factorial times 1 factorial times 1 factorial times 1 factorial for the consonants. So it's equal to, we have 720. Another example. In how many ways can 4 girls, okay, 4 girls and 5 boys be arranged in a row so that all the girls are together? Okay, so the girls wants to be together, so this is considered as one group. Okay, plus, of course, these 5 boys. So we have here 6. Okay, so 6 factorial times, again, the arrangement of the 4 girls. So that's 4 factorial times the arrangement of each of the boys. We have there 1 factorial times 1 factorial times 1 factorial times 1 factorial times 1 factorial. Okay, so we have there 17,280. Okay? Next, we have here 12 points lie on a circle. How many cyclic quadrilaterals can be drawn by using these points? We have here, for the quadrilaterals, this is 4. So we have there 12C4, and that is equal to 495. Okay? Next. Okay. So in a box, there are 5 black pens, 3 white pens, and 4 red pens. Again, we need the black pens and the white pens and the red pens. Okay, so for the black pens, we only need 2. For the white pens, 2. And for the red pens, 2. Okay, from the available 5 black pens, 3 white pens, and 4 red pens. So that would be 5C2 times 3C2 times 4C2. And that is equal to 180. Next. Okay, so a question paper consists of 10 questions divided into 2 parts, A and B. Okay, so each part contains 5 questions. Excuse me. A candidate is required to attempt 6 questions, in all of which at least 2 should be from Part A and at least 2 from Part B. So in how many ways can the candidate select the questions if he can answer all questions equally well? Okay, so let us divide the 10 questions, A and B. So 5 from A and 5 from B. Okay, so the candidate is required to attempt 6 questions, at least from 2 from A and at least 2 from B. So let's start first with 2 from A. So that would be 5C2 times, if the candidate answered 2 questions from A, then he needs to answer 4 from B. Okay, so that would be 5C4. Okay, then he can also choose to answer or decide to answer 3 from A, so that would be 5C3, and 3 from B. Or, again, he can decide to answer 4 from A, so that would be 5C4, and 2 from B. Okay? So, he can choose from this or this or this. So, that means you need to add. Okay? So, all in all, we have there 200. Next. Okay? So a committee of 5 persons is to be formed from 6 men and 4 women. Okay? So 5 persons. In how many ways can this be done when at least 2 women are included? And another question is, at most 2 women are included. So let's start with this one. Okay. So if we are going to include at least 2 women, so that would be, if we have 4, that would be 2, 3, and 4. Okay? So from 4 women, we can include 2. So if we have included 2, then we can get 3 from the group of men. So that would be 6C3. Okay? Or that would be 4C3 from the women, and then from the men, we have 6C2. Okay? Or we can include all the women. So 4C4 times, so how many more, or how many person are we going to include from the men? We have 6C1. Okay? So that is equal to 186. Okay? What about at most 2 women are included? Okay, so if it's at most, then it would be 2, 1, 0. Okay? So this would be 4C2 times 6C3. Okay? So if you are going to include 1 from women, we have there 4C1 times 6C4 from men. Okay? If we decided not to include anybody from the women, then that's 4C0 times 6C5. Okay? Then this is, oh, it's also 186. Okay? And then, for our last problem, the Indian cricket team consists of 16 players. It includes 2 wicket keepers and 5 bowlers. In how many ways can a cricket 11 be selected if we have to select 1 wicket keeper and at least 4 bowlers? Okay, so if we have 5 bowlers, at least 4 is 4 or 5. Okay, so let us list down. We have 16 players. From 16, we have 2 wicket keepers, then 5 bowlers. How many were left? We have 9 players. This is from the 16 players. We only need how many? 11 players. Okay, so that 11 players, we need 1 wicket keeper, then at least 4 bowlers. Okay, and then of course, this will vary the players. Okay, so for this problem, we have there 2C1 for the wicket keepers times 5C4, okay, times 9C. If we have here 1 and 4, then how many were left for the 11? We have there 6, okay, plus, okay, so we have again 2C1 for the wicket keeper times 5C5, okay, times 9C5. Okay, so again, this is for this one, at least for bowlers. So this is equal to 1092. Okay, so that's all for now. Thank you very much, and may God bless you.